Hey everybody, this is Mr. Longo, and in this video we are going to cover basically an introduction of sequences and some patterns. This unit is going to focus on sequences and finding sums of sequences, both arithmetic and geometric. So what we're going to do is kind of start to talk a little bit about what some of those sequences are. Arithmetic has a common difference, meaning it goes up or down at the same rate. But it's going to be by adding or subtracting. So in this case, 2 plus 2 is 4, plus 2 is 6, plus 2 is 8 if it goes up, or if it went down, subtracting 2. To the next one, if it's by adding or subtracting, that is known as an arithmetic sequence, and the rate that they change is called the common difference, also known as D. If you are multiplying, or dividing, which is still multiplying by a fraction, that is called a geometric sequence, and the rate that you change is called the common ratio, known as R. So that would be 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay? So sometimes you have to do something as simple as just list the next couple of terms of a sequence, but then we're also going to use patterns and rules to figure out what certain numbers might be. So this example, you have to first decide, are you adding, subtracting, multiplying, dividing? So to get from 11 to 8, you would subtract 3. So the first thing you would do is check by subtracting 3 to get to the next one, and it works. So you're subtracting 3, subtracting 3, subtracting 3 again. So if you just continued subtracting 3, you would be at a -1 and a -4. Okay, to get from 1 to a -4, that's subtracting 5. So if you subtracted 5 more, you'd be at a -9, not a 16. So this is not going to be arithmetic. So you try geometric. 1 times a -4 gives you a -4. -4 times a -4 is a positive 16. So you figured out this one. So this one is multiplying by a -4. So if we multiplied a -48 by a -4, that would give us 192. Multiply that by a -4, and you get -768. Okay? So that is what we are doing when we're just filling out patterns. This last example, this is multiplying by a half or dividing by 2. It's the exact same thing. So half of 2 would be 1, and half of 1 would be 1/2. And yes, fractions are allowed. So just keep on rolling with it. Okay? So the next example is when you're given a pattern rule listing the first 3 terms. So some more notation that you need to be aware of. A sub n is the actual term, and n represents the number of the term. So this says list the first 3 terms. So that means a sub 1, that means the first term. A sub 2 would be your second term, and a sub 3 would be the third term. So since n is 1, all you have to do is substitute a 1 into your n's. N squared is 1 plus 1 is 2 over 1 is 2. Then you substitute in a 2. 2 squared is 4 plus 1 is 5 over 2. And finally, a sub 3, 3 squared plus 1 is 10 over 3. So that is an example of a pattern rule that all you have to do is plug in the number of the term, and that will give you the term. Okay, so 3 is the term number. A sub 3 is equal to 10/3. It's the value. Okay? So, working backwards, here is another pattern. I would like you to think of the pattern rule. Now, at times, this is a little tricky, and sometimes you'll have to guess and check. But you have to remember, you are thinking about comparing to the actual term number. So a hint is sometimes this is the first term. This is the second term. This is the third. This is the fourth. Okay? So why don't you see if you can think about what your rule for this might be. And if you came up with n plus 1 over n squared, you would be correct. Because if you look at the top, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. So your numerator is just going one above the term number. And the bottom is just being squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, and you get it, okay? So that's working backwards. So sometimes you're given a pattern and you have to write a rule for it. Now again, sometimes that's a little tricky and you might guess, which is fine. The last thing is known as a recursive pattern. So recursive means you are comparing to the previous value. So in order to have a recursive sequence, you must have the first term. So we know that a sub 1 is equal to 5. And if we're finding the first 3, then we need to find a sub 2, and we need to find a sub 3. Now, another notation that you need to be aware of is this a sub n minus 1. A sub n minus 1 means previous term. So if you have a previous term of 5, so once we get to a sub 2, that means it's 3 plus 2 times a sub 2 minus 1, which is a sub 1, which takes you back to the previous term. Okay, that's how this works. So 3 plus 2 times your previous term, which is 5 times 2 is 10, is going to give you 13. A sub 3 would be 3 plus 2 times 13, which would be 29. Okay? So that's it for this video on sequences and patterns. Moving forward, we're going to talk about some arithmetic and geometric sequences and also finding sums of those as well. This is Longo and I'm out. See you, bye.